Now we will begin section 613, Systems of Linear Inequalities. Graph the solution set of each system of inequalities. Name 2 points that are part of the solution set. Example 1. We're given the system of inequalities. X plus y is greater than 6. And 2x minus y is greater than 4. So we need to solve by graphing. That's really the only way we can solve this. To solve a system of inequalities where you're dealing with less than or greater than symbols. First, we need to get the inequalities into slope-intercept form by isolating y in each one, by getting y by itself on one side of the inequality sign in each one. Then we can graph it. So x plus y is greater than 6. X is being added, so to get rid of it, do the opposite and subtract x from each side. X minus x is 0, so it cancels out. Y is greater than, and for slope-intercept form, put the x term first, then the constant, the number not multiplied by x. And it's positive 6, so put plus 6. So now it's in slope-intercept form. We have y, and then on the other side, an x term and a constant. Let's go ahead and graph that. And let's put 6 tick marks on each side. 1, 2, 3, 4, 5, 6. Usually a good rule of thumb is to put 6 tick marks on each side. Y-axis, x-axis, 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. I'm going to go up by 2 for the numbers. -2, -4, -6. Same thing for the negative y-axis. Alright, so negative x is the same thing as negative 1x, which is the same thing as negative 1 over 1x, because multiplying and dividing by 1 does not affect the value. But now we can see that the slope is negative 1. Whenever it's in slope-intercept form, the number that is multiplying x is the slope, which tells you how steep the line is and in what direction it's going. And the numerator of the slope tells you the vertical change, which means up and down. The denominator tells you the horizontal change, which means left and right. And the constant, the number not multiplied by x, is the y-intercept. It's where the line crosses the y-axis whenever it's in slope-intercept form. So it crosses the y-axis at 6. Let's plot that point. And every time there's a vertical change of 1, there's a horizontal change of 1. For the vertical change of 1, I'm not going to go up 1 because that's going to take me off the graph. I'm going to go down 1 for the vertical change of 1, and for the horizontal change of 1, I can go 1 to the left or 1 to the right, but it needs to be 1 to the right, so that way when I connect the points, the line goes down as it goes from left to right, like it's supposed to, because it's a negative slope, -1, or -1 over 1. And then down 1 again for the vertical change, 1 to the right, again for the horizontal change. And just keep doing that until you get to the edge of the graph. Down 1, 1 to the right. Down 1, 1 to the right. It's easier with graph paper. Down 1, 1 to the right. And then now we're at the edge of the graph. You can keep doing that forever, down 1, 1 to the right. Use an arrow to indicate that the line goes on forever in that direction. And you could go back to the y-intercept, and for the vertical change of 1, this time go up 1. For the horizontal change of 1, this time go 1 to the left. And you can keep doing that forever, up 1, 1 to the left, up 1, 1 to the left. But we're at the edge of the graph. We don't want to go off. We don't want to go off the graph. So draw an arrow to indicate it goes on forever in the other direction. There is no little line for equal to underneath the inequality symbol, the greater than symbol. So actually we need to have a dotted line to indicate that points on the line are not part of the solution. So if you substitute in coordinates of any point on the line in for x and y, it would produce a false inequality. Now let's get the other inequality given to us in the problem into slope-intercept form by isolating y, getting y by itself on one side of the inequality, on one side of the greater than symbol. So subtract 2x from each side. Since it's positive 2x, to get rid of it, subtract 2x from each side. 2x minus 2x is 0, so it cancels out. We get negative y is greater than, and for slope-intercept form, put the x term first, then the constant. It's positive 4, so put plus 4. We have negative y isolated, but it needs to be positive y isolated. Negative y is the same thing as negative 1y. If there's no number, you can just insert a 1. Y is being multiplied by negative 1, so to get rid of it, do the opposite and divide each side by negative 1, using a fraction line to indicate division. So now the negative 1's cancel out, because negative 1y divided by negative 1 is positive 1y, and y times positive 1 is just y. Each term gets divided by negative 1. Negative 2x divided by negative 1 is positive 2x. 4 divided by negative 1 is negative 4, since a positive divided by negative is always negative. Now it's in slope-intercept form because we have y, and then on the other side, an x term, 2x, and a constant, negative 4. The constant, whenever it's in slope-intercept form, tells you the y-intercept. So where the line crosses the y-axis, which in this case is negative 4. So I plotted that on the y-axis. And then the number that's multiplied by x is always the slope whenever it's in slope-intercept form like it is here. So the slope is positive 2, which is the same thing as 2 over 1, since 2 divided by 1 is 2. The numerator of the slope tells you the vertical change. The denominator tells you the horizontal change. Remember, vertical means up and down. Horizontal means left and right. So every time there's a vertical change of 2, there's a horizontal change of 1. So starting at the y-intercept, negative 4, for the vertical change of 2, I'm going to go up 2. And for the horizontal change of 1, I can go 1 to the left or 1 to the right. But it needs to be 1 to the right. So that way, when I connect the points, the line goes up as it goes from left to right, like it's supposed to, because it's a positive slope, positive 2, or positive 2 over 1. If it was a negative slope, I would have to make sure that the line's going down as it goes from left to right. And for the vertical change of 2, I'm going to go up 2 again. For the horizontal change of 1, I'm going to go 1 to the right again. And then just keep doing that until you get to the edge of the graph. Up 2, 1 to the right. Up 2, 1 to the right. Up 2, 1 to the right. And it keeps going like that forever, as indicated by the arrow. And then go back to the y-intercept, and this time for the vertical change of 2, go down 2, and for the horizontal change of 1, go 1 to the left. And you can keep going down 2, 1 to the left forever. So draw an arrow to indicate that. And because there's no little line for equal to underneath the greater than sign, points on the line are not part of the solution, so we need to draw a dotted line to indicate that. Okay. So now we need to figure out what region we need to shade. Well, in both inequalities that we got into slope-intercept form, we have y is greater than. Y is greater than negative 1 over 1x plus 6, and y is greater than 2x minus 4. Anytime it's y is greater than, that indicates the region above the line. So it's y is greater than in both situations. So we need to shade this region here because this is the only region that is above both lines. And just keep in mind that this shaded region actually goes on forever over here. Keep in mind that these dotted lines go on forever in these directions. So yeah, anywhere between the dotted lines that go on forever is where the shaded region goes on forever. So any point in that shaded region, if you substitute in the coordinates for x and y in both of the inequalities given in the problem, it would produce true inequalities for both. That's how you can check the answer. Now let's go to example 2. Example 2. Solve by graphing which is really the only way you can solve a system of two inequalities. The system given to us in this problem is x is less than or equal to 4 and y is less than 2. All right, this is going to be much faster and easier to graph because it's just x or y on one side and a number on the other side of the inequality. So to be safe, it's good to have at least 6 tick marks on each side, but we only need 4 tick marks on each side for this one, since we have x or y on, for each inequality we have x or y on one side and a number on the other side, and there's no number there that goes past 4. So we only need 4 tick marks on each side. Two, three, 4. 1, 2, 3, 4. Okay, 2, 4, 2, -4. Okay, so now it's all set up. X, well, first let's draw the boundary line. X equals 4. Let's ignore the inequality for now. Let's just draw x equals 4. Anytime it's x equals a number, it's a vertical line. And because we have the little line for equal to underneath the less than symbol, it's a solid line to indicate that points on the line can be part of the solution if they border the shaded region. So this is the line x equals 4 because it goes through 4 on the x-axis, and every point on this line has an x coordinate of 4. Now let's graph y equals 2. Let's ignore the less than sign for now. Let's graph y equals 2. And there's no little line for equal to underneath the inequality symbol, so we need to use a dotted line to indicate that points on the line are not part of the solution. They just serve to, the line just serves to border the shaded region and let you know where the shaded region ends. Anytime it's y equals a number, it's a horizontal line. This is the graph of y equals 2 because it goes through 2 on the y-axis, and every point on this line has a y coordinate of 2. So if it's, now let's focus on the inequality signs, the less than signs. We have x is less than 4, so that indicates this entire region to the left of the solid line x equals 4. Because everywhere in this region, the x coordinate is less than 4. And we have y is less than 2, which indicates the region below the dotted line y equals 2. Because everywhere in this region has a y coordinate that's less than 2. So the region we need to shade is this region here. Because this is the only region that fulfills both conditions of being below the dotted line y equals 2 and to the left of the solid line x equals 4. Every point in this shaded region has an x coordinate that's less than or equal to 4 and a y coordinate that's less than 2. Points on the solid line that border the shaded region are also part of the solution, because points on that line have x coordinates less than or equal to 4, and y coordinates less than 2. So it says in the directions, I just didn't write it down, name 2 points that are part of the solution set, which I forgot to do in example 1, but I'll do it here. So 2 points that make both inequalities true if you substitute in the coordinates for x and y in the system given to us in the problem. So I'll just pick 2 random points, either in the shaded region or on the solid line that borders the shaded region. Let's see, I could go with this point here. That works. That's in the shaded region. And that's the point 2, 0. Always put the x coordinate first, then the y coordinate. It's 2, 0 because it's on 2 on the x-axis and lines up with 0 on the y-axis. I could go with this point here. That's on the solid line bordering the shaded region. That's the point 4 for the x coordinate, comma -3 for the y coordinate, because it lines up with the -3 on the y-axis and 4 on the x-axis. But I could have picked any 2 other points in the shaded region or on the solid line or on the solid line bordering the shaded region. And keep in mind that the shaded region goes on forever in this direction, because these lines go on forever. Now let's go to example 3. Example 3, solve by graphing x plus y is less than 5, and y is greater than 4x. Let's get both into slope-intercept form by isolating y in each one. So we have x plus y is less than 5. Subtract x from each side. X minus x is 0, so it cancels out. We get y is less than, and put the x term first for slope-intercept form. Then the constant, the number not multiplied by x. It's positive 5, so put plus 5. Negative x is the same thing as negative 1x. If there's no number, you can insert a 1. And negative 1 is the same thing as negative 1 over 1, because negative 1 divided by 1 is negative 1. Dividing by 1 does not affect the value. So now we know the slope is negative 1, or negative 1 over 1. The numerator tells you the vertical change. The denominator of the slope tells you the horizontal change. And the constant is the y-intercept, where the line crosses the y-axis. let's begin graphing now. Let's put 6 tick marks on each side just to be safe. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4. Oh, I ran out of room. Oh well. It'll probably be fine. X, -2, -4, -6, -2, -4. Okay, so the y-intercept is 5, so let's plot 5 on the y-axis. And every time there's a vertical change of 1, there's a horizontal change of 1. For the vertical change of 1, I'm going to go up 1 from the y-intercept. Remember, vertical means up or down, horizontal means left or right. For the horizontal change of 1, I can go 1 to the left or 1 to the right, but it needs to be 1 to the left. So that way when I connect the points, the line goes down as it goes from left to right like it's supposed to, because it's a negative slope, -1 or -1/1. And then you can keep going up 1, 1 to the left, up 1, 1 to the left forever, but that's going to take us off the graph. Just draw an arrow to indicate it goes on forever in that direction. And make sure to make it a dotted line, since there's no little line for equal to underneath the less than sign. And now go to the y-intercept, and this time for the vertical change of 1, go down 1, and for the horizontal change of 1, go 1 to the right this time. And then down 1, 1 to the right. Down 1, 1 to the right. Keep doing that until you get to the edge of the graph. Down 1, 1 to the right. All right, we're at the edge of the graph. You can keep doing that forever, going down 1, 1 to the right, so draw an arrow to indicate that. Now let's get the other inequality into slope-intercept form. Y is greater than 4x is the same thing as y is greater than 4 over 1x plus 0, because 4 divided by 1 is 4. So the y-intercept is 0. It crosses the y-axis at 0. So plot that point. And every time there's a vertical change of 4, there's a horizontal change of 1. So for the vertical change of 4, I'm going to go up 4 from the y-intercept. And for the horizontal change of 1, you need to go either 1 to the left or 1 to the right, but it needs to be 1 to the right. So that way when you connect the points, the line goes up as it goes from left to right like it's supposed to, because it's a positive slope, +4 or +4 over 1. And then you just keep going up 4, 1 to the right forever. So draw an arrow to indicate that. Now go back to the y-intercept. This time for the vertical change of 4, go down 4. And for the horizontal change of 1, go 1 to the left. And I'm using a dotted line because there's no little line for equal to underneath the greater than symbol. And you keep going down 4, 1 to the left forever. Draw an arrow to indicate that. Now we have to figure out what region to shade. So, and to do that, you focus only on the slope-intercept form for each inequality. So for the first one, we have y is less than, which indicates the region below the first dotted line we drew. So this region here. And for the bottom inequality, we have y is greater than, which indicates the region above the second line we drew. So this region here, above this dotted line. So we need to shade this region here because that's the only region that fulfills both conditions. That's underneath the first line, which is y is less than, and above the second line, which is y is greater than 4 over 1x plus 0. And keep in mind that this shaded region goes on forever because the lines go on forever. All right, so to name 2 points that are part of the solution set, you can name any 2 points in the shaded region, such as this point here, which is -2, 3, because it lines up with -2 on the x-axis and 3 on the y-axis. Or you can go with this point here, which is -4, 1, just another random point in the shaded region, which is part of the solution set, because it lines up with -4 on the x-axis and 1 on the y-axis. So if you substitute in, let's say you're checking to see if a -2, 3 is really part of the solution set, you can do that by substituting in -2 for the x's and 3 for the y's in both inequalities, and if it makes both inequalities true, you know you have the correct answer, which you would. It would make both inequalities true because it's part of the shaded region. And you can check -4, 1 in the same way. Now let's go to the next example problem. Example 4. Example 4. This video is running long, so I think I'll probably skip the next example problem that I was planning on doing and just going to the one after that. So let's solve by graphing y is greater than or equal to x over 2. So this time we have a fraction. And y is less than x plus 1. Let's get the top inequality into slope-intercept form. Y is greater than or equal to x over 2 is the same thing as y is greater than or equal to 1/2 x, because x is the same thing as 1x, since x multiplied by 1 is just x. And then you can just take the fraction outside of the variable, and then plus 0. So it's in slope-intercept form because we have y, and then on the other side an x term and a constant. The constant, whenever it's in slope-intercept form, tells you the y-intercept, where the line crosses the y-axis. The slope is the number multiplied by x whenever it's in slope-intercept form. The numerator tells you the vertical change. The denominator of the slope tells you the horizontal change. Let's go ahead and start graphing. Let's just put 4 tick marks on each side because we're dealing with pretty small numbers here given to us in the problem. 1, 2, 3, 4. Well, let me just make sure that that's going to work. Okay, 4 tick marks on each side. 1, 2, 3, 4. 1, 2, 3, 4. But it's usually safer to have at least 6 tick marks on each side, so to make sure that you get the proper point of intersection. And putting the numbers in. -2, -4. Okay, so let's plot the y-intercept, 0 on the y-axis. And every time there's a vertical change of 1, there's a horizontal change of 2. Vertical meaning up and down, horizontal meaning left and right. For the vertical change of 1, I'm going to go up 1 from the y-intercept. And for the horizontal change of 2, I can go 2 to the left or 2 to the right. But it needs to be 2 to the right, so that way when I connect the points, the line slopes upwards as it goes from left to right like it's supposed to, because we have a positive slope, positive 1/2. If it was a negative slope, I would need to make sure that the line slopes down as it goes from left to right. And I'm going to go up 1 again for the vertical change and 2 to the right again for the horizontal change. and it keeps going like that forever, up 1, 2 to the right. Draw an arrow to indicate that. And this time we do have a little line for equal to underneath the greater than symbol, so we need a solid line to indicate that points on the line are part of the solution if they border the shaded region. Now go back to the y-intercept, and this time for the vertical change of 1, go down 1, and for the horizontal change of 2, this time go 2 to the left. Down 1, 2 to the left. Then it just keeps going like that forever, down 1, 2 to the left, as indicated by the arrow. Now let's get the other one into slope-intercept form, which it pretty much is, because we have y, and then on the other side, an x term and a constant. So the constant is the y-intercept. So it crosses the y-axis at 1. Let's plot that point there. And x is the same thing as 1x, since again, x times 1 is just x. And 1 is the same thing as 1 over 1, because 1 divided by 1 is 1. The numerator tells you the vertical change, the denominator tells you the horizontal change. So every time there's a vertical change of 1, there's a horizontal change of 1. So starting at the y-intercept, for the vertical change of 1, I'm going to go up 1, and for the horizontal change of 1, I can go 1 to the left or 1 to the right, but it needs to be 1 to the right, so that way when I connect the points, the line goes up from left to right like it's supposed to, because it has a positive slope, positive 1 or positive 1 over 1. And then up 1 for the vertical change, and 1 to the right again for the horizontal change. Just keep doing that until you get to the edge of the graph. Up 1, 1 to the right. It's easier with graph paper. And then back to the y-intercept. This time for the vertical change of 1, go down 1, and for the horizontal change of 1, go 1 to the left this time. Down 1, 1 to the left. Down 1, 1 to the left. Down 1, 1 to the left. We're at the edge of the graph. And we do not have a little line for equal to underneath the inequality symbol, underneath the less than symbol, so do a dotted line to indicate that points on the line are not part of the solution. And it goes on forever in this direction, as indicated by the arrow. Now we need to figure out what region to shade. And make sure you only look at the slope-intercept form for each inequality. So here and here. And in the first case, we have y is greater than or equal to. So that indicates the region above the first dotted line, or the first solid line that we drew. So this region here. And in the second case, we have y is less than. So that indicates the region below the second dotted line that we drew. So this region here. So the part that needs to be shaded is, let's see, so above the first solid line that we drew and below the second dotted line that we drew, that's going to be this region here. Because that's the only region that fulfills both conditions of being above the solid line and below the second dotted line that we drew. And that shaded region goes on forever over here because both lines go on forever. And any point in the shaded region or on the solid line bordering the shaded region is part of the solution set. And if you substitute in the coordinates of any of those points and for x and y in both inequalities, it would make both inequalities true. So in the directions, which I did not write down, it wants 2 points that are part of the solution set. So I'm going to pick a point from the shaded region, just a random point. Let's go with this point here, 3, 2. Lining up with 3 on the x-axis and 2 on the y-axis. And I can pick any other point in the shaded region, or a point on the solid line bordering the shaded region. I'm going to do that. That's going to be 4, 2. X is 4, y is 2. So those points are examples of 2 points in the solution set. Okay, so that should be good enough for section 613, systems of linear That concludes section 613, systems of linear inequalities. Thank you.